see, just sit on the table so we can get started. We have let's see, how many people are here at a Thai event for the first time? 5, 6, okay, and there also, okay. And how many of you are not Thai members? Okay, so there were 3 or 4, okay. Let me just give you a quick overview of Thai for the benefit of those who are here for the first time. Thai started about 21 years ago, and it was started by 5 or 6 entrepreneurs who were successful beyond their wildest dreams, thanks to the magic of Silicon Valley. And so they thought that they got together to figure out how to give back to the society. And they brainstormed over a period of 6 months and finally came up with this idea that the best way to give back to the society is to encourage wealth creation through entrepreneurship. So the recipe they came up with was that most highly successful people would be invited to become what they call charter members of the organization. But in order to become part of the exclusive club, you have to be committed to paying forward, giving your time, what is most valuable to you, not money, but your time, for the benefit of the next generation of entrepreneurs. And that recipe of making it an exclusive club, but a club not for social purposes, but a club for the purpose of promoting entrepreneurship, the recipe turned out to be very potent and it traveled extremely well. So now Thai exists in about 60 different chapters in 17 different countries. And some of the latest chapters are in Lisbon and Brussels and Japan, Israel, those kind of places. So this concept has traveled extremely well. In terms of things that Thai does, historically you should do 3 things. One is inspire people to become mentors. Second thing is educate about entrepreneurship and about different opportunities in different segments. And third one was mentoring. So giving your time for the benefit of the next generation of entrepreneurs. Historically, that's what Thai did. Lately, we have started a couple of other things. We have added, 2 things to the mix. One is funding. So we have this program called Thai Angels. So how many of you are entrepreneurs here? Okay, so good number. So for those of you who are seeking funding, or those of you know people who are seeking funding, tell them about Thai Angels. This is basically an angel investor group of the Thai community. We have funded 20 companies now over 2.5 years for a total of about 7 million plus, and about 8 of them have received VC funding after that, so they have done extremely well. So that program is going extremely well. The second thing they are about to start is this accelerator incubator called Thai Launchpad. And if you have time after this, you just go across this aisle from the back, and that's the startup space. And starting October or November, we'll select about 8 companies, and each company will get $50,000 on very generous terms. And essentially, the purpose of this thing is to accelerate their development to a point where they can get funding. So customer development would be emphasized, and again, a hands-on mentor who's a domain expert would be paired with the company, and that mentor has to spend at least 1 to 2 hours a week with the company for 5 months, and and open up the Rolodex for the benefit of the entrepreneur. So that program is starting. We'll start to talk about how to submit applications and stuff. Please talk, spread the word and talk to your friends who are thinking of starting a company. That would be a great program. So those are the things we do. In addition, we have special interest groups in different hottest areas of technology, and one of those special interest groups is one that has organized this. So this might be a great segue for me to invite to see our very, very active board member in charge of programs. He has come up with really innovative programs, and one of them is My Story. The next My Story is, you should all attend, is the story of the founder of Nicera. Sold it for $1.2 billion to VMware, and that's on the first Tuesday of September. Second Tuesday. Okay, all right. So that's right, yeah. So we started programs, and we have a number of different special interest groups, and big data is one of them. So, so the person behind all of these things is our board member Naveen Bisht, and this is, please give him a hand.
Let's give a big hand to our chief volunteer, as I call. Venk Sukla, who is president of TIE since early this year, and he gets paid a lot, 7-digit salary. But only thing is, it's all zeros. There's no one in the front. So let's give him a real good hand. So really is great and keeps excited. So like I said, without taking any much more of your time, Venk already mentioned about all the great programs. So this those who are interested in the new emerging trends in the software, in the infrastructure area, we have one on Monday called Software Defined Storage. So really a high-class panel, and those who are involved in infrastructure. So we have on Monday evening, same time like this, which is part of our Software Defined Infrastructure industry segment. Like this is part of big data, and then we have this My Story on September 10th. Nicera co-founder Martin started over the years, since they are the ones who pioneered in this whole HDN space. So anyway, what I would like to do is introduce our two co-chairs for this. So idea is not like my brainchild. As I was telling you, this is all about entrepreneurship, and one of the lessons I learned in entrepreneurship was always anyone who I went for advice, they said get A+ people in your team, right? So whenever I did my startups, so I always made sure I did that. So what happens is, I always made sure those guys are very smart, so I chose two. We had Piyush, who all of you already know, and Piyush is the worldwide leader in big data at IBM, so let's give him a big round of applause. So he is a co-chair for big data industry segment with Karthik. Karthik, again, he's been with a number of startup companies as co-founder. Last company co-founder, VP of marketing, which was Status, which was bought by VMware, and now in fact he is the head of their analytics products, I guess, for Pivotal Labs, which is again a spin-off of EMC, VMware. Recently, I'm sure you guys know, it's the highest revenue startup, about 350 million right from the day one they got started. So,
good evening, everybody. Thanks for showing up this evening. And today, actually, happens to be a very power-packed panel that we put together. And the way I want to do this is, I want to introduce the panelists here as stating name of the person as well as their company, and when they come on the stage, then they'll talk about themselves and their company and what they do and something specific about big data and monetization. So please welcome on the stage here, we have Dr. Amit Narayan from AutoGrade. To his left is Krishna Namagada from Intel. His company Extreme Insights was just acquired by Intel. Then we have Kathy Yu Chang. She's the Senior Director at Impetus. And finally, we have Ron Bodkin, the CEO of ThinkBig Analytics Consulting Company. All of these are very accomplished professionals. You can read their bios on the screen. Not on the screen, but when you registered for this, you saw that they have not only achieved excellence in academics, but also many of them have patents in this space, and many of them have worked with clients, and you'll hear their stories as to what they are working with big data. So I'll just set the context here. to begin with, and then we can go and talk about each of their stories. And each of them will take about 10 minutes, and after that, we will bring question and answer from the audience. Everybody ready? All right. So, when you think about big data, a lot of us talk about big data and we think about something. We're reminded of an animal, right? The elephant. Correct? Okay. Okay, you guys are silent right now. Alright, metaphorically speaking as well as literally, somehow big data has always been associated with big volumes of data. And that reminds people of the technology that is very popular in the space, which is Hadoop, and the symbol thereof, elephant. But again, big data does not equate to only Hadoop. There are a lot of things when we talk about big data. There's big data at rest, there's big data in motion, there's big data in place, and we should be talking the entire gamut of things. So hopefully through the use cases today, you'll get to see that. Now, but it's an animal land in the big data space. There's a lot of hype. A lot of people are talking about it, but not very sure that people are actually addressing how we are making money, what is the monetization, what is the ROI. So that's what we've asked the panelists here to talk about. Now, and all outside there's a lot of big data washing happening. Everybody is talking about big data, even though they may not have worked or they may not have products in this space. So to separate myth from reality, that's another thing that this panel will try to do. And just want to set the context here. When we talk about big data definition, it's the 4 V's: the volume, velocity, variety, and veracity of data. Now, there are others who have invented other V's, and they keep talking about a lot of those things, variability and value and whatnot. Yes, we'll get to value in a bit. But we'll stick to the 4V definition, standard that we at IBM adopt and talk to our clients. But at the same time, our technologies here in big data, as they appear to be nascent, they are maturing to a certain extent, but again, NoSQL and other innovations are happening there. Now, Gartner just recently came up with their hype cycle, and I just wanted to show you here. This hype cycle actually is talking something different from what they talked last year. They're saying that big data will take another 5 to 10 years to mature. You can see this plateau out here. I don't know if this works or not, but regardless. So it means they have been talking to people. From my personal experience with clients worldwide in my services business, I have talked to a number of clients around the world. People are excited, they are educating themselves, they are empowering themselves, and they are experimenting, which is all good. But very few people are in production with respect to big data, barring many companies here in the Silicon Valley who have been at the forefront of big data. So we will today address those things from a perspective of what the common companies are doing and what the internet startups are doing in this space. Now, when, again, the story of elephant and the 7 blind men, right? Everybody has a different perspective of big data. So we want to actually address the elephant in the room here. And yes, big data can be a funny business. Big data has become a common buzzword, and very recently, since the NSA leak issue came up, it's become, data actually has become dinner table discussion at every home. Everybody's concerned about privacy. Everybody's concerned about metadata. Think about it. I've been doing the data business for the last 20 years, and I had trouble explaining metadata to my kids. Now everybody gets it. So, but talking about big data, the myth is that it's not a technology. Big data is not only a use case, and it's not only a technology. It's the movement which demands more value from all data. So there are different layers here, and this build will show that there is the hardware with platform at the end, then there are the big data engines, and the data sources and tools thereof. There are different end user tools as well as productivity tools, and there are different companies in this space. Of course, Pivotal, IBM, Oracle, Dell in the infrastructure space. You see Amazon, Google, Microsoft. I won't read all these names, but you can see they are full of established as well as startup companies out here. Now, we in IBM have seen adoption of big data, working with more than 2,000 clients over the last couple of years. The use cases can be classified into these 5 main cases around exploration of big data or enhancement of 360 view of customer or database augmentation. And this is one use case which has actually saved a lot of sleepless nights for a lot of people, because we are seeing more and more folks who did not have the advanced data scientist skills. They are now confident that they can leverage the emerging technologies of big data and still be happy. So with that, I will end my preamble here and invite Amit, Dr. Amit Narayan, on the stage to talk about his company, Autograde.
Thank you. And thank you everyone for taking the evening to come here and listen to what Autograde is doing. It's a great opportunity for us. So as Piyush mentioned, there's a lot of companies and a lot of work which is going on in the big data space in general. What our company is trying to do is make sense out of all of this infrastructural work that is going on to solve some specific problems around energy. And you might have heard of the term that data is the new oil. We actually use the term that we are turning big data into power, because we are specifically focused around the electricity supply chain, how electricity is generated all the way to how it is consumed, and try to drive efficiencies throughout the supply chain so that we can reduce the number of power plants that have to be built to keep the lights on. So again, I don't know how many of you are familiar with the electricity infrastructure. There has been a lot of hype around the smart grid or the intelligent grid, and over the last few years there is tremendous amount of infrastructure that has been put in place to modernize the grid, both on the transmission side of the grid as well as on the distribution side of the grid. And this infrastructure has come in the form of meters that can continuously monitor and send usage patterns back to the utility companies. It has also come in the form of automation of facilities, whether these are large industrial or commercial facilities or even residential facilities where more and more people are getting connected to wireless thermostats and other types of devices in the home. But there's also a tremendous amount of instrumentation which is going on the distribution networks and on the transmission grid. And all of this infrastructure that is coming in place is creating massive volumes of data. And surprisingly, the use cases around that data have not been really well thought through over the years. So one of the opportunities that we sort of identified was how can we now use this data, couple it with an understanding of how the overall physical infrastructure works, and then drive efficiencies throughout the system. And this is just a quick team. We are your regular software team. My background was designing semiconductor chips. I was writing software which was used to optimize chips. And as you can imagine, a chip, even though it's a tiny system, it's incredibly complex in terms of number of transistors that are around there. But what I realized about 3 years ago, that laws of physics actually don't change too much when you go from one domain to another. And it turns out that these chips, even though they're tiny, the frequencies on these are very, very high. And so every single metal line starts behaving as transmission lines. And we knew, just to keep up with the Moore's law growth, how to model millions and hundreds of millions of these transmission lines very well. And then, as it turned out, power system research declined dramatically around the world, especially in the US in the 70s. So we thought that we could use some of the technology that was developed in the context of semiconductor and apply it to understand what the smart grid really means at a much deeper engineering level instead of just building Excel models and high-level economic tools. So we thought we could now comprehensively model exactly how will be the transfers to the grid once we understand the physics behind it. So that was an idea, and my background, I know some of you are interested in this, looking at startups. I was not in this industry, but this idea appealed to a number of people, and eventually I was invited by Stanford to start a research group at Stanford, and that's where I sort of developed myself a bit further. And then I hooked up with people from PG&E and other utilities who were in this space, who were looking at this problem. So both our VP of Biz Dev and CTO used to run this problem. Yeah, sorry about that. So we are, as I mentioned, we are a software company. We have been looking at big data even before the term was popular in almost every domain of data science. People from our team have done some work, but we have coupled it with a deep domain expertise in the space. And in the last few years, we were actually one of the early ones in 2011 who realized that with all this data coming in, this is actually going to become a big data problem in the traditional ways of storing the data in SQL databases and trying to manipulate are not going to scale. So now mainstream media has picked up on that, and we have been getting quoted in the press quite a bit around that. And we are also working with some of the leading research organizations in this space. So fundamentally, the problem that we are trying to solve is that historically utilities were collecting 1 meter read a month, and in some countries they were actually collecting 1 meter read a year, and in some countries actually they asked their customers to just report what their usage is, and then every 2-3 years they verify and check, and if there are some discrepancies they basically and if there was a power failure, they would wait for somebody to call before they would even know whether there was a power outage in a particular geography. Now, as I mentioned, in the last several years, through pioneering work by companies such as Silver Swing Networks, who's one of our partners, and Itron and others, there's a lot of connectivity that has gone in on the electricity grid. And most of the meters that have been put in typically today report 15-minute reads back to the utilities, which is already 3,000 times more data than what these utilities are used to seeing. But these meters are also able to collect sub-10-second reads, and over the internet, through a gateway, they can send that back to utilities, and many utilities are now trying to see how they can take advantage of that. And so the number of data coming and amount of data is just exploding. And we see a lot of hype around Internet of Things and connected devices. This is a study from McKinsey which shows that utilities actually are one of the places where number of connected devices are exploding out of all the industries which are out there. And actually, before I go this is also probably one of the industries which is least prepared for this data tsunami, because most of these utilities don't have a big R&D grid that can deal with this data. And as these devices grow, and I can go into more of these statistics, but many people don't realize even today there are lots of devices that are already connected. There are 13 million homes that are on some sort of a pager-based demand-side management program, for example. But as these technologies grow, the traditional problems that we see with large volumes of data come here, both in terms of application response time and system cost. And so what we are trying to do is use the techniques of cloud and big data to keep this linear and scale as this data grows. Now, one of the things that we are doing here is, as Piyush mentioned earlier, there is no single technology that can solve all the use cases or all the problems that are specific to a particular industry. So you can use Hadoop and you can do really good batch processing with that, but you also need to do stream processing, so you will need another framework for that. In this particular industry, we have to see how the system evolves, so we need linear solvers, non-linear solvers, convex optimization solvers, understand the physics of the grid. And you may need some in-memory processing and so on. So we create a full stack so that end customers don't have to worry about trying to figure out what is the best Hadoop distribution and what's the best streaming solution that they need to use. And we package it for this industry so that all the databases are set up in a way which are most optimal for the use cases in this industry. And the second issue that is very unique to this particular industry that we are dealing in is that there are many different devices, and they generate data which sits in many different databases, and there are some very deep divides on how the industry is organized. So that creates all kinds of problems in terms of information sharing, vendor log, operating costs, and so on. And so what we are trying to do here is actually create a new data model which fundamentally combines this new data with a deep understanding of the field. And that's very unique because traditionally these two domains have been very different. People have not been able to see how the voltages and power flows and power phase angles would evolve as the data on the grid is changing, and being able to create that. And then we create a number of common engines that are needed for various types of applications. So one of the things in big data, in my opinion, which is happening, which is the big trend, is to see how certain business processes can be completely transformed by using big data. And I think that's probably one of the biggest opportunities out there. And one of the biggest transformations that is happening is in the utility industry. Now that we have data coming in from so many different sources, you have this opportunity to fundamentally transform how these utilities are being operated, both for revenue management perspective, but also in terms of how we optimize their operations. And so this is something our platform allows. We allow customers with their utilities, but also other partners who might be selling applications to the utilities to create new types of applications that don't tend the cost and time that it would take to build these applications from scratch. So we just announced a partnership today with one of the largest IT companies in Japan, one of the top 5 in the world, NTT Data, which is adopting our platform now to build their own applications, which are outside of the utility space. They're serving customers who are using electricity and helping them manage their electricity better. And so what we're trying, I don't know how much time do I have, I can go on. Yeah, okay, so let me just, you can talk to me afterwards. I didn't see the slides before they were sent, so I think I'm just clicking through them right now to see what shows up. Okay, what is it? Well, I mean, hopefully, usually it's better if people tell you what they sent, but I think they did CC me, and it's probably my fault.
That's why it's not posted yet.
Yeah, okay, cool. So I'm happy to talk about what we are doing. I think the main takeaway is that there's a big industry, there's a big transformation happening, and I think the data we can really make a huge improvement in productivity.
Thanks, Amit.
A short intro. I'm one of the partners of Extreme Insights. We were a Hadoop and big data consulting firm, recently acquired by Intel. I know most of you don't need any introduction to Intel. You know who Intel is, but maybe one thing that you don't know is Intel is big into big data, Hadoop, and the software. So I don't have a lot of slides on what Intel is doing, but I wanted to spend some time on showing you some of the use cases we have seen out there as part of our consulting. And see how you can derive value out of it. So if you're looking at starting a company or doing a service or creating a product, what are the areas in big data that you can look at? And those are the kinds of things that I want to talk about. So here I use Hadoop as synonymous with big data, but whenever you hear Hadoop, think of it as the ecosystem. It's just not Hadoop, but anything with NoSQL, all the other big data technologies as well. But Hadoop is the fancy name, it's got a fancy logo, but so just use Hadoop as synonymous with everything. So what can Hadoop help customers with? What can the newer companies do with Hadoop, right? So we have classified these into 4 different things, right? So one is discovering and experimenting. Anytime you have lots of data, you can discover and experiment with it, right? Hadoop enables you to do that. And the other one is building applications, right? Whether it's real-time inventory personalization. I have listed, I'll not read all of those, but these are like the traditional brick and mortar enterprises that are using Hadoop to build applications. The third one, again, not the least important, is reducing cost of information. What the big data technologies are enabling is reduce the cost of information, whether it's storage of information, processing it, analyzing it. It's a paradigm shift. The cost is so low now these days that companies will tend to store everything and anything they can store. And the last one I have here is around modernizing mainframe, and I know Piyush wouldn't like it, but there's a lot of money that people spend on pay to IBM for maintaining their mainframes. So what we have done at prior to Extreme Insights, I was at Sears, where
we migrated mainframes to a Hadoop-based infrastructure. So it runs at 1/10 or 1/5 the cost of an IBM mainframe and much more faster. Again, there are lots of, didn't mean to generalize it, there are a lot of bells and whistles you get with IBM, you don't get that with Hadoop, but you save the money.
There's an IBM distribution of Hadoop as well, which has all those
Yeah.
enterprise scale things. I don't represent that, but I just wanted to clear that.
So the other thing I know, I didn't want to take on Piyush, but Piyush said, I agree with Piyush when he said there's not many companies outside of the valley that have been successful in doing big data. But from a consulting perspective, I disagree on that. There are a lot of companies in the Midwest and East Coast that are looking at Hadoop. Not from a fancy real-time analytics, but more from the last 2 or 3 parts on this slide, right? How do I save money? How do I build applications to run on Hadoop? How do I pay less money to Teradata's or IBM's of the world? Optimize, not pay them at all, but how do I optimize my cost? That's one of the major drivers for companies. Yeah. Fortunately, I've been lucky to be involved with some of these deployments. Like I come from Chicago, I've just relocated here. So like any company you name, like in the Fortune 500, most of them are looking or have a POC at Hadoop. There are many production implementations as well. Some of the few I know, like Sears, Kohl's, McDonald's, they're all looking at Hadoop, right? Just let's take an example of McDonald's. I mean, nothing confidential here, but if you look at McDonald's and the scale that they operate at, they have so many stores, so many people are buying. If I'm an analytics guy, I want to know on a summer sunny day when the temperature is 70 degrees, are people buying coffee with muffin or are they buying just the hash browns? So that's the kind of information that McDonald's wants, but unfortunately they don't have. They can't store all of that. Their transactions get summarized. In a traditional ETL world, you get the raw transactions, you summarize it, put it in a star schema, put it into a data warehouse. Your user wants another field, it takes ages to get the product, right? What Hadoop does is it shifts that paradigm. So you're storing data in its raw format. All the transactions are there. It's cheap enough to store. Most of the time it's cheaper than tape, probably. It's an intelligent archive, so they can dump all the transactions and read and analyze whatever they want. So that's the power that enterprises are looking in with Hadoop. And the major vendors are not able to provide that. And that's why they're embracing Hadoop. So any media companies, right? You look at the media companies. So earlier, companies would sell a DVD. You bought it, you watched it. That's it. Now you consume media in multiple devices. You might be watching on iTunes. You might be watching on your computer, or you might be renting from Redbox. You might be buying a DVD. So how does all this information correlate? Right? Advertisers are going back to Disney and asking, hey, I want to know where people are fast forwarding a movie or where they're watching it multiple times. Based on that, they want to advertise, or companies want to see if they can sell chapters of a movie. So that's a lot of information crunching that's not economically possible in traditional technologies, and that's why companies are embracing Hadoop. So it's not a silver bullet. There are a lot of challenges with it, but that's the only game in town right now. In terms of being cost effectively monetizing your data. And again, another basic fundamental thought I want you guys to leave with is, why are companies storing so much data these days? Anybody? No. Storage is cheap. And also look at us, right? We are leaving so much data footprint. I don't know about many of you, but if you look back a few years, your Hotmail was like what, 1 MB, 5 MB, 10 MB? Now you look at our Gmail inboxes, you have tens and 20s of gigabytes of emails. You upload tons of pictures, you upload videos. How much digital footprint are you leaving? So that all needs storage, right? And companies, when they know you as a person, they also want to look at your footprint. So companies have started to store your interactions, not just the transaction. They want to look at how you're interacting with their website. They want to look at how you're talking to them. They want to look at what you're posting on Twitter. So auto insurance, traditional auto insurance is they look at your driving history, give you a quote, no accidents, you get it. But that's going to change. And I can't name the insurance firms, but they're implementing solutions where they look at your Twitter or Facebook and say, hey, you have been racing or something, your premium automatically goes up. This is real, and they're doing it. And the states are trying to do it too. So it's everywhere. So anytime you're on the internet, anytime you're on Gmail, so all information, nothing is secure. It's there. There are privacy laws. but companies can analyze it. Google advertises on your Gmail. It reads your Gmail. I mean, it's not the person, but it's a machine learning algorithm that reads your email and advertises next to it. So nothing is secure. And all this is driving to where? Because companies want to predict what you want to buy. Companies want to predict what you want to read. That's the only differentiator. When they want to do that, they need lots of data and they need lots of information point, and that's where Hadoop comes in. So you store everything. It's cheap, as you said. It's cheap. It's cheaper than, if you look at SAN, it's 10,000 a terabyte a year approximately. Any MPP is $50,000 a year. Approximately Hadoop is $2,000 a year. So when you store more data, when you think it's worth more than what it costs to store. Earlier it was not worth, or people didn't think it was worth because it was expensive to store. So having said that, I wanted to show this just to see it's not only retail, but it's across any industry that you look at, right? So you have the core functionalities that the industries have, whether it's customer insights, price optimization, or recommendation engine for retailers. Just affinity analysis, right? What product sells next to what product? How will people buy? All these are a lot of compute-intensive and storage-intensive things. So this slide applies for any industry. You just have to replace them with their industry-specific things. Like similarly, insurance, fraud analytics. You have insurance companies monitoring your driving habits, right? So I speak to insurance companies on their use cases. Now they want to store every turn, every brake, everything that you do on your vehicle to get more predictive things or to get more accurate behavior. Earlier they were just storing not that many data points. We have seen in the auto grid example too, like one meter reading per month to 3,000. It's the same thing that the insurance industry is going through. They want to capture all of your things and analyze and give you a better quote or save money. And again, where does the business value come? Just taking my time. Where does the business value come? In a retail case, it's all marketing intelligence, right? Are you reaching the right customers? Are these customers my most profitable? Who are my most profitable customers? So those are all ROI driven. Those all have payback. And we spoke about ETL reduction. Why is there a need for ETL when all of your data is in Hadoop? You can have your layers within Hadoop. We call it the Facebook model. You would have like a staging layer, then you would transform it, create an enterprise layer, create a gold layer. So you're minimizing the ETL overheads. So those are some of the advantages that companies are seeing. Again, price optimization, how to mark down a particular item. So you might find it, like if you closely observe your retail shopping pattern, you might find the same item priced differently in different stores, the same chain. Maybe you go to Home Depot in one location, it's priced higher than another. Because they have to analyze all the demographics of the users around the store. What is their price sensitivity? What is their demographics? Are they more Asians? Are they more, simple things like, Costco knows that Asians shop a lot more times and their shopping basket is smaller. So they need to change more items when there are more Asians. If it's Caucasians, they know that their basket size is bigger, they're less price sensitive probably. Or if there's another demographic. So they have to build all of this into their product assortment, and it's not easy. Again, we spoke about cost of information, right? Moving to Hadoop platform. These are some charts we have found when we did real work, right? We spoke about the storage cost of MPPs versus SAN versus Hadoop. And we also spoke about the mainframe cost. So you can offload mainframe batch processing onto Hadoop. Just to not only to reduce cost but also to improve your performance, and also from a skill set perspective. If it's legacy and Hadoop is one of the new kid on the block, latest technologies, people will be excited about learning it. So we encourage companies to explore Hadoop for their batch processing. Wrapping up. So we spoke about the telematics example, looking at all the vehicle pattern and things like that. Text analytics, how are people talking, converting voice to text and doing all those analytics. So those are all ROI-based initiatives. It's not just a fancy project. There is ROI on these projects, and we have seen CIOs and CTOs put in these initiatives. Said that, thanks.
Thank you, Piyush. So when I got invited for this, I looked at the title "Big Data Monetization." I immediately thought of big monetizing on big data methods, big data platforms, big data processes, and the interesting thing is it can be interpreted as selling the data, big data monetizing by trading or bartering or selling the data, or big data generated businesses that monetize. So I decided to make a couple of changes to the title. One is I called the set of slides Big Data, Fragmented, Challenging, and Full of Opportunities. Opportunities in this case speak directly to monetization. And in the slides itself, I'll use the word value and explain where I see the different value and how they show up in real cases. So the event itself is very timely, like Piyush was saying about the Gartner hype cycle. So I personally don't think we're headed towards the trough of disillusionment. I think there is a significant amount of opportunity. So hopefully all four of us can be sharing some of the observations as well as experiences in terms of successes. There are certainly challenges, but successes there as well. So we have a big data situation just to establish a platform, baseline rather. So when traditional information systems can't store, analyze, there's some display issues, but that's okay. So store, process, analyze, the 4 V's, I'm missing one here, veracity, and then in the cost or time we're willing to pay for that kind of process. So big data, in terms of monetization or driving value, there's 3 ways that we should look at value being realized. One is revenue, generating revenue. One is reducing cost. And third is reducing risk or increasing compliance. And the first 2 are harder than the third, meaning the first 2 are hard benefits, whereas the last one's more of a soft benefits. And I would argue that financial services is probably the only industry out there that really understands risk. So some may disagree, but so revenue, cost, and risk. I will give an example of use case in each. So Impetus Technologies has worked with a media company, so industry is media, on revenue generation. So in this particular company, they were looking to put together a new business for their Hispanic consumer data analytics, so they can make money by advertising, by making recommendations, and such. So here's a case of revenue generation in media. Next, a cost reduction situation where we have a telecom company that's looking to fund a big data project. The problem is they weren't going to get the funding they needed, but there's good news. They can consolidate what they had, and they were actually able to take 48 RDBMS licenses out and save hundreds of thousands of dollars and be able to fund the project for their Hadoop and Hadoop type project by themselves rather than using additional funding. So that's an IT transformation for big data in telecom, cost reduction. And third, as I mentioned, financial services is probably the only industry that understands risk. In this particular case, a large credit card company was looking to reduce their false positives for their fraud detection in credit card transactions, and we were able to help them potentially save $112 million a year by reducing the risk of customer churn and other things related to a large number of false positives in their credit card transactions. Okay? So Impetus has helped these customers in, depending on where they were in their adoption process. We sometimes start from the strategy perspective, identify the use case, help them discover and prove the value of the project. Sometimes they already understand what they need to do, and they need to understand what technologies may be appropriate for their project. So that's when we get into a proof of concept and help them validate those technologies. And finally, if they like what they see and if they are expected to realize the value they set out to realize, we implement and make sure they're successful. So, a couple words on Impetus, based out of San Jose, founded in 91, relocated to San Jose in 96. The first big data project was in 2007, and we can help, and we're hiring.
I did a PDF because I was afraid that my Mac version of PowerPoint wouldn't translate properly, so I did a PDF to minimize that risk. So while we're pulling the slides up, I'd love to give a little introduction myself. So I'm the founder and CEO of Think Big. Prior to starting Think Big, I really started my big data journey as an early employee in a company called Quantcast. Quantcast, its initial mission was measuring the internet, directly measuring every page view, every advertising campaign. At a time when the companies that were doing that, Nielsen and Comscore, said it wasn't possible, too many hard statistical problems, you had to use small panels and correction techniques to estimate internet traffic. We went ahead and started doing it, and very quickly we outstripped what was feasible for a startup to do with a database technology and said, we need to do something else. We were going to, in fact, go ahead and implement some kind of one of our founders had come from Alta Vista, for those who remember that. It was one of the early search engines before Google took over the world there, and had experience with how do you build a specialized system for processing massive amounts of data in a sort merge system. Unfortunately, Google had written a paper right around that time on MapReduce, as well as some of the related technologies that we take for granted now. And we got excited by the fact there was an open source implementation that had just come out as part of the Nutch project, which was, of course, Hadoop. And so we put Hadoop into production in 2006. And when Facebook was coming out asking, how are we going to work with all the data we've got? We had a relationship with Facebook, and we showed them what we were doing with Hadoop, and they said, wow, this could really work. Fast forward a couple of years as Quantcast had accumulated over a petabyte of data. It now has 50 petabytes. And we had built up a very sophisticated Hadoop infrastructure, integrating with massively parallel database. When we went looking for NoSQL technologies, there wasn't anything mature on the market. We built our own. Of course, fortunately, there's better options than building our own today. And we did a lot of distributed machine learning. So in my time at Quantcast as the VP of engineering, I had a chance to lead the engineering and data science teams and had the golden opportunity to live in the future. Because, as has been alluded to by the other speakers here, very few companies today are sophisticated in big data. We all know who they are, right? So there's companies like Quantcast in the advertising ecosystem. Of course, Google and Facebook and LinkedIn and Twitter and so forth are poster children, right? So in this area, within a short drive of this very location, are many of the leading companies in terms of actually applying big data in the world. But I left Quantcast back in 2010 because I felt that this was just the start of a much bigger revolution, that the way that big data was going to change the economy to become data-driven and to drive efficiencies was going to be a major importance, that it was really going to unleash a productivity boom, like the productivity boom that computer automation unleashed in the 1990s, and that there was a chance for us to create a company that would do something special, that would unleash that as a catalyst for creating value in the world out of big data. And so, of course, we're all in on big data. Unlike many companies that have a big data practice and were started a long time ago, we are all in. We believe it's fundamental. We're 100% focused, exclusive on it. There was some discussion around people trend jacking and talking about what they're doing as big data. But our company, we're exclusively focused on helping companies get measurable value from big data. We'll talk a little bit about that. I should say, we have a services model. We think that what's important in this space is the high value applications of big data are not a simple thing that can be put in a box and packaged. There's a lot of great point applications for big data, but the highest value comes from blending your data sets with third-party data sets and creating something that's unique to your business. So we'll talk a little bit about that. But fundamentally, at Think Big, we are working with leading enterprises across many industries and creating solutions that leverage big data in ways that were never before possible. Now, I want to touch a little bit on some of the dialogue earlier about, well, what is big data, right? And I think it's important to say that big data is a term that's stuck for a concept that's out there And when people give you definitions of it, they're really more archaeologists defining characteristics. And that's different in the sense that you can't say, well, how much volume of data is big data? What level of variety is it? What level of veracity, as opposed to what, the lack of veracity in old data? I don't know. But, the point is that really, what I think is maybe the most useful operational characteristic of big data is that it's exceeding what was reasonable to do with legacy data processing technologies. Because let's face it, our world of data processing the last 30 years has been dominated by the designs of data systems, analytic systems, processing environments based on computers that are a million times less powerful than the computers of today. That we were designing databases to work on machines that were far worse than this device here in my pocket, right? And of course, there were a lot of constraints in that world that meant we had to make compromises that aren't applicable to today's world. So big data is about fundamentally having designed a new set of technologies for storing and processing data that are based on scale-out clusters and that are rooted in the innovation of open source as a foundational principle. And that's what drives the kind of disruptive economics we've heard about here today. So that's some thoughts on that. I should note that also at Think Big we're hiring, so definitely excited to bring in talented people that want to be part of that. At Think Big, we've done work across a number of industries. We've worked with some leading companies, whether it be a network appliance at Axiom, some leading financial asset firms. I have to be pretty careful about using names of companies like that sometimes. We've worked with a lot of great organizations across many industries, helping them really apply big data, get to measurable value quickly. And we work with companies both in terms of thinking through strategy as well as quick execution of results, right? So, we see here that, of course, big data can be useful, whether it be in driving customer support from device data, whether it be blending online and offline data for marketing, whether it be useful for really better understanding your customers if you're a large financial firm. Now, one thing that I think is really important to think about is that when you think about the ways that you create value out of big data, we think about it in terms of what are the stages of adoption? What's the evolution of value creation in an organization that's using big data? And these stages have mostly come from the future. The few companies that are actually fairly mature in using big data that have gone through these phases. Because as many folks on the panel previously have articulated, most organizations today are in stage one. They're still doing traditional BI, maybe thinking about how do we start getting something out of big data. Many of the enterprises that have made production deployments, and there's a lot, are into the next stage of cost and scale, which is characterized by really more of a focus on IT resource business cases, things like shifting mainframe processing, offloading, cost containment on the data warehouse, those kind of use cases that we've heard a lot of discussion of already. We see, though, as organizations mature, the next stage is to start saying, there's more to big data than just cutting IT costs. There's a lot of value in the agile analytics that can be done. The not being constrained by a system where you have to organize all the data up front and pre-process it to answer specific questions is one of the most powerful elements of big data. You can work with data in a more complex way, and the kind of use cases that come from that of agile analytics, of blending data sets you never before anticipated, of pulling out results with data science and working with more raw data, but with sophisticated analysts that can understand what's going on, are powerful indeed. And that's really a next stage of value creation that many use cases fit into. As you go further up the curve, you start to get into cases where you're no longer just getting insight, but you're now starting to drive systems of engagement, and you're starting to automate responses in the enterprise. So, for example, at QuantCast, we rolled out of our fantastic database a revenue-producing product called Lookalikes for the fast-growing real-time bidding advertising ecosystem, where we would build predictive models. And as events were coming in and web pages were being rendered, we'd bid on exchanges and say, within milliseconds, and say, well, it's worth this much to buy an ad on this exchange at this time, right? So that's a predictive model that tends to blend both real-time big data systems like NoSQL and Storm with more batch-oriented machine learning and scoring and technologies like Hadoop. And then finally, we see organizational transformation is important, which is more about becoming a data-driven organization and starting to launch new products and offerings with big data as a foundation. Just to touch briefly on an example of some of the value creation in another area, one of the things I think that it was touched on a little bit is Internet of Things. We see a tremendous amount of value that's available in not just in customer data, but in machine data and device data. So when you look at things like storage systems providers, companies that have large equipment stored in their customers around the globe, there's tons of opportunities to scale the infrastructure and to start to provide better analysis and better support for those customers, driving savings in both in terms of equipment, for sure, storing the data and processing it, but more importantly, driving better customer results. So, when you think about generalizing that, there's a lot of technologies that go into Internet of Things analytics. There's a lot of elements ranging from real-time response and visualization, ad hoc analysis, being able to dig into a specific issue and actually have a system where you can ask the question. I think that's one thing that's often not appreciated is it was easy to store data in a raw format prior to big data, but it was almost impossible to find anything or do anything with it. Suddenly with big data, you can look into data and say, well, what's going on? Let me troubleshoot the problem. And as well as ultimately do things like build predictive models that start to highlight the things that are relevant and let you get to faster analysis. So those technical capabilities we see playing out in the Internet of Things to drive results like better customer service. How do you find the drivers of customer satisfaction and produce better results? How do you reduce churn? How do you cross-sell? How do you start to take best practices guidance for customers and guide them on what they can be doing better based on what their peers are doing, what other customers are doing, right? So we see whether it's driving up customer satisfaction, improving sales, or even creating new offerings, or informing product management, starting to understand what the customer of your product is actually doing to tailor the way you manage your product. All of these are great opportunities that are really unleashed by the use of big data around device data, blended with more structured data like who are your customers and what are the transactions. So we often see the architectures for big data that create value as blended. Right? It's not a single technology, as some of the other panelists have said, but it needs to be able to support a variety of use cases. These can be built incrementally over time, and the good news is we're seeing increasing investment in enterprises that are realizing value incrementally by a quick rollout of capabilities. So that's a little bit of an overview. So maybe that's the last slide. And with that, certainly look forward to the panel discussion here today, and appreciate your time today.
Thank you, Thomas. With data, and many experts think that the term big data itself will go away. And do you guys think it's the same? If each of you can take turns, starting with Amit.
Well, I think that, I think I've said this before, but I think there are only three things that are certain in life: death, taxes, and big data. So I don't think this is going to go away. I mean, the term may change from big data to smart data or something like that, but I think the amount of data is only going to increase, and I think that's just a reality of life right now.
Share the microphone with Krishna.
Yeah, I think it's just data, but if you say data, you don't get the attention, so people tend to say it's big data. But if you look at it, it's just data. It's the changing time, right? You have seen in many Gartner studies and all. So we have created, in the last 2 years, we have created so much more data than we have ever done in the last 100 years. So it's just data. So going forward, it will just become data.
Kathy?
Similarly, I think it depends on who you speak with, and some people think what they have as data is big data, whereas some others, they have significant amount of data or significant variety of data. They because they deal with that on an everyday basis, they don't look at it as big or small. So for the term, I think it's the big that's going to get redefined. Data will stay there.
Certainly from my view, right now we're in the middle of this big transition in data architectures, right? So what's driving the term big data is the fact there's a disruption, that the old database and analytic architectures are not doing the job. And big data is a term to describe the characteristics of all the things we want to do with data we never could, right? That transition will play out over the next few years, and as it becomes standard and mainstream, you're going to see a lot less use of the term big data. And that doesn't mean that the need is there. Data volumes will continue to explode exponentially. If anything, the ability to do something with all that data is triggering an increase in the production rate of data and the retention rate of data, right? Instead of saying, we'll only capture that if something goes wrong, people start saying, well, let's store it because we might be able to analyze and create value, right? So the data volume explosion is going to be accelerating, but the term big data is going to become just part of the environment. People will just be used to, there's techniques for working with data. Of course we use these flexible data processing techniques. I mean, just like today, people still have mainframes, but they're kind of antiquated. People will look at, the old relational techniques and the old processing environments of yesteryear in the 1980s, 90s, and zeros is the old way of doing data.
All right, so definitely the term data will stay. So one question for Krishna now. You talked about in your talk about how insurers are getting a business model in which they are able to charge variable amount based on how they are using or driving their cars. The question is, how are they getting that data today?
I think it's similar to what Amit showed in the auto grid, right? So insurance providers will give you a device that you can put in your car. So in return, they'll give you a discount on your policy. So you're letting the insurance company monitor your driving habits, and they give you a discount. So
similar to maybe a healthcare provider giving you or implanting a chip in you, so that they give you discount on your insurance policies.
They actually do that, not a chip, but you might have healthcare policies in your companies, right? They say, hey, do this annual physical, or if you quit smoking, we give you a discount. It's nothing but the same. They want to monitor your habits, your health habits. Pretty soon they'll monitor your eating habits and everything and roll it up into your healthcare costs. And one thing that I have for people in the room here is healthcare is kind of the sleeping giant for big data opportunities. I've interacted with multiple insurance firms and healthcare companies, and they don't have a clue on how to correlate data. When I say they don't have a clue, the systems are so antiquated. As basic as, are you obese? How do you define obese? Right? The insurance company doesn't have from your provider what's your height, what's your weight. Because after a particular age point, our height remains the same, and the weight might go up, down, whatever, right? So even that, hospital discharge notes, and those kind of things. So there's a lot of room for opportunities here if people are thinking about startups. Healthcare companies are there with Obamacare coming up. You can just do a simple test. You can ask your provider how much they charge you for a particular procedure they do on you. They don't know because it's so complicated. They have different chargeback mechanisms, and healthcare will be like a big thing, and particularly.
Absolutely. So one question for Kathy now is: open source has driven this big data movement so far, and do you think it will continue the same way, or something different will come, or different business models will come?
Yeah, I think open source will. Open source is one of the driving factors of big data growing to where it is today, and I think it'll continue because if you look at the historical trends in the Linux, Unix, the days, and database, there's open source trends in each of these spaces, and going forward for big data specifically, there will be some concerns about the reliability, the viability of companies, and some of the quality issues that with people putting their big data into these systems focused on open source technologies. But those issues can be addressed. So business models new business will come out of this, and companies, IBM, the Intels, and Pivotals, and the other Hadoop companies and NoSQL companies, a lot of companies contribute to open source. So it's going to be there, and it will drive additional businesses and provide additional opportunities for entrepreneurs as well.
Right.
Yeah, I just want to add on that. We hear a lot of customers taking the view that they feel the safest in investing in community-based open source. That they feel like they know. I mean, customers have become sophisticated, and they recognize that there's a lot of risk in buying infrastructure from a startup because the startup might go out of business, or the startup might be so successful that they get acquired by Oracle. And then what are you going to do, right? So, the net effect is that we see companies saying that, at least if we're buying something that's based on community open source, we won't be hard for us no matter what happens with the particular vendor we're working with, right? So we see that as, customers saying, we're just going to give the extra chance to a leading open source technology because it's a standard. And maybe there's some proprietary innovation over here that looks appealing, but we'd rather get the open source version 6-12 months later than bet on something unproven, right? So, one thing I like to say, I think it's worth thinking about as an entrepreneur is, if you think it's hard to make money in an open source business model, try making money competing with one.
Anyone else want to add? All right. Are there any questions from the audience? Yes. Can we get the microphone, please? Just introduce yourself, your name, your company affiliation, and then the question, please.
My name is Raghu Kopale. I've I'm a struggling entrepreneur. The startup is struggling. Called Clearstream in the home automation and streaming home automation space. Now, the question I have is, seems like Hadoop is the sort of a golden standard middleware or the layer that interfaces all these blocks you have on the left. Is the industry driving towards any standard from the communication from the end device and the app development perspective, so everything gets sort of like Apple creating a platform for app developers, sort of a type of a thing for the IoT, any device can use XYZ protocol for transmission aspect, and this particular app development platform or app for transmitting data to the Hadoop layer.
Well, it's a great question, right? So certainly for Internet of Things, there's some emerging protocols like IQTT and a few others, but it's still very early days in terms of different kinds of devices, different kinds of data, have different ways of transmitting the information. So it's still nascent, I would say, kind of having clear establishment of standards. There are a number of technologies that are becoming increasingly important for loading data into big data environments, right? So technologies like a Kafka, like a Flume for loading data into Hadoop that's unstructured, or Scoop and some related database technologies for structured data. So there's some emerging standards in the space, but like a lot of what's happening in big data, you've got typically multiple open source implementations out there, and people needing to kind of decide and see which one ends up getting the most traction in the market.
Yeah, just to add to that, injection, maybe there will be some standardization there, but when it comes to data science and analytics, every company wants to have their own secret sauce. If that formula works for every company, then they don't have a competitive advantage. So whatever data science or predictive things they're doing, companies wanted to keep it as their secret sauce. So there'll be a lot of custom development that will continue to happen for the next few years.
Anyone wants to comment on the visualization aspect as well?
I think there's a lot of elements of visualization, right? We see people having needs from sophisticated data scientists that want to do very custom, complex ways of looking into data deeply, through to tools to make business analysts more productive on top of data that's in a more raw form and get some useful insights out quickly, through to packaged visualization insights for end users, dashboards, attractive reports. It's still early innings, right? You see more traditional players like a Tableau bringing their, they're an innovator in relational analytics, but bringing their platform and adding more support for big data. You see companies that are more focused on disrupting, like an Alpine Data Labs or a Platform or a Datameer out there trying to do more in that middle ground of serving business users, giving them tools to do their own analysis, and then the use of technologies like R and other open source analytic environments for allowing data scientists to dig deep into data and visualize things exactly the way they want.
Yeah, I think that's a good point. Yeah, like wherever we go, companies want their business analysts to go and analyze the data without the need for IT. And Hadoop and some of the visualization tools like Datameer or Tableau enable that. And the new innovation is in the graph analytics. There'll be a lot more of graph coming on top of big data. So that's one area which will continue to be investment will continue to go into graph databases.
Kathy, you worked at Datameer, so you have some other perspectives?
One thing I was thinking when Ron and Krishna were talking is I think visualization, in a way, levels the playing field for people who use data and who want to get the insights so they can either perform what they need to perform or do a lot more than they could before do without the visualization. So in a way, it's making the data come to life so that they can actually get the value out of it.
Maybe I agree with everything, but as other people noted, there is just so much fragmentation in the industry that standardization across all the industries is unlikely to happen, and that's where creating vertical stacks for specific industries have value, where you can create adapters and connectors which work for a particular industry. And then, for example, in our industry, there's a lot of standardization happening around communication from in-home devices and meters and other types of sensors back into the back office, and we support a number of those standards as well, and there's adoption. But trying to force that standardization across every industry is going to be that much more challenging when it's challenging in one particular area.
The fragmentation that you talk of, any nascent technology fosters that. Entrepreneurs basically have their different ideas and backed by VC money. They want to do that, right? Only when things mature, settle down, the real value that people start seeing, then consolidation happens. In the big data space, what's your prediction when the standardization will start happening? 5 years from now, 2 years from now, or 10 years from now?
Well, as I was saying, it's hard for me to predict in the big data space, but at least from the energy space, we see quite a bit of standardization beginning to happen, both in home energy monitoring. There are a couple of standards. I mean, it's not fully sort of sorted out, but the number of standards have gone down, and there are 2 or 3 standards that are getting a lot of traction at this point. So I think that's already happening in certain industries, and I think others can comment on their specifics.
Kathy?
I was going to say, I think you can wait till Oracle acquires Cloudera or Microsoft acquires Hortonworks and then say, hey, it's getting consolidated. But until then, it's fragmented. If you have an idea, you build a connector to work with PeopleSoft, it's up there. Somebody will come and buy you. You can have an early exit. So.
You know what happened? You didn't name IBM acquiring anybody.
IBM already has a lot of their own things, so they don't need anybody.
Maybe I'll let Mohan talk about things, and I know not many people.
No.
Yeah, go ahead. Mohan has a question.
No, I wanted to make a point. I'm Mohan from IBM. Just to maybe put the record somewhat straight, since you guys painted a very rosy picture of all this Hadoop and everything. I don't know if any of you in the audience was at the meetup that the Hive guys had on Hadoop and SQL. Yeah, that's true. You were there. The story there was, this was TM Ravi and the usual companies were represented on that panel. In spite of all the ease with which people would do a variety of things on their own, you don't need SQL and so on, the contrary point was made over there that the largest set of skilled people out there are the ones that are, very knowledgeable about SQL. So things are being turned around now where the stuff that got thrown out is now coming back, meaning higher level query language is being shoved on top of Hadoop, so that the trusted tools and the knowledge that's out there in the regular shops as opposed to startups and so on doing stuff. So in terms of money making also, it remains to be seen as to how much real money the infrastructure companies can make in producing software that addresses this kind of market segment. It's cool to talk about all sorts of things being possible, but who's going to make money? I mean, we haven't sold anything to the Web 2.0 companies, right? So should we take their requirements so seriously and believe that that will become the broad-based requirements for large number of companies who are willing to pay money to buy products? And so who's the guy who's ultimately going to spend the time to build all this? It's true that initially all these open source things got kicked off with the Web 2.0 companies contributing a whole lot. But in the longer run, we are not in the charity business, right? So somebody has to make money to justify spending money on developing these things. I don't know what you're...
All right, any counterpoint to that?
Yeah, but I think that certainly one thing that's very different about big data is it's a first significant technology where the innovation is being led by open source, right? That until now, you've seen open source be a follower of mature technologies. So we're all kind of forecasting an unknown future as to how that plays out. But I think, when we see customers, like literally, we're now talking to innovative enterprises, not companies out here, but companies in the middle of the country that are dealing with problems of, we have too many Hadoop clusters. We've got dozens of them and we want to consolidate into multi-tenant clusters with that are better utilized, right? That's not a problem of a technology that's at risk of going out of business. That's a problem of how do you start to solve kind of the next generation of problems of something that's succeeding, right? So I don't think there's any question that there's going to be a role for big data more broadly in the industry. To the point of Hive being important, I don't think NoSQL is a term that's maybe even worse than big data, right? In the sense that NoSQL, again, was a kind of term that described a characteristic of a very different technology in the big data space, honestly, of databases that had some nice characteristics. And at the time, what seemed interesting about them is they didn't support SQL. Well, defining anything in terms of a lack of a feature is a kind of a weird definition, right? Because it's not good. SQL actually is a great thing, right? So people have discovered, wouldn't it be great if we had a mix of ways of working with data? We had more flexibility than with traditional relation. We didn't have to have everything highly normalized and perfected. But that doesn't mean that existing skills should be thrown away, right? So I think you're going to see integration and blending, right, is the other thing. Is you don't see big data coming into the enterprise and tearing out your existing systems and saying, well, we'll get rid of the warehouse, chuck that thing, we'll go ahead and put something new in it. Instead, you see people augmenting and extending. So it plays out over time, and there's, of course, a role for a variety of companies to support big data.
Yeah. Supporting SQL on Hadoop is part of that, right? Making it accessible to enterprises. Like if you look at it like Formula One to regular cars, like Google's and Facebook's are like the Formula One. You have the coolest technologies, but can regular cars use it? Unless it's toned down, it cannot. So we have seen at Sears and other traditional enterprises I've worked at, they need SQL. That's the core, and that's why companies like Intel they're investing in making Hadoop SQL 92 compliant. So the existing systems will stay there. Hadoop is like a supplement, and it'll enable them to do a lot more at a much lower cost. It's not going to replace, or as you said, whip about anything.
Great. Let me.
Yeah. So what we're seeing is we have our innovators, and we have in the technology adoption cycle that Jeffrey Moore has laid out. You got your early adopters, you got your early majority, you got your innovators, early adopters, and early majority. So we're right at, I claim, we're right at getting to the early majority part. And for the early majority to accept the technology and to really jump on the bandwagon, they need to see successful cases. And how they see successful cases is they need to see companies like them, or companies bigger than them, companies that are more mature than them, the companies that they've been successful accept that technology in their space. So for that to be adopted, there are certain changes or there are certain adjustments that need to be made. And the big opportunities for all of us come when we push the technology to the plateau of maturity.
There we go, audience question there.
Yeah, my name is Guru and I'm from Mindtree. I have more of a philosophical question in the sense that is big data really a solution or a problem? I'll come to it.
Can you keep the question?
Yeah, Krishna explained that with a McDonald's example on how the big data is helping get the burger sell and things like that. But what I feel is that once you have the big data, then it becomes more of a problem than a solution. I mean, what's more important is that particular McDonald's store to understand what is selling at what time and to create a solution around it. Than going to a big data where a big guy is sitting there and telling you, hey, you guys are going to sell this and this is what's going to make sense. So your comments, please.
You're right. I mean, big data is part of the problem, but the solution, somebody has to implement those insights, right? I mean, they know what's selling, what's not selling. But the actionable insights out of big data is the challenge. How can you get these insights and how do you implement? Again, I think Ron had a good slide where it showed the organizational change as well. So it's not only enough if you're capturing all the data and if you have the analytics, it's not good enough. Somebody has to act on it. And that's a culture change for every organization. Same with the McDonald's example, right? So they need that because the franchisees can do something, but overall McDonald's needs to grow as a company. So there are only so many people, and if they're every day eating 2 burgers a day, what more can McDonald's sell, right? So that's what they're trying to figure out. So same with any retail or anything consumer oriented, right? So when they get saturated, they're looking at means to sell more or differentiate. And you're right, it's part problem and part solution.
Every coin has two sides, right? So in fact, I was about to bring out the issue of data-driven culture and how and why it is important for the success of a big data program. In fact, not only big data program, any data initiative in an organization, until the mindset of the organization is changed. So change management assumes a very great significance in the initiatives. So, you want to add something?
Well, I just wanted to say it's neither a problem nor a solution. It's an opportunity, right? So if you can differentiate that.
Be positive, look at opportunities. That's an entrepreneurship model. All right. Any other questions from the audience? All right, please. Dan, can you get back?
That's okay, I'll just ask
For the recording. And who else? We can take one more question after that. So. Sure.
My name is Rahul Deshpande. I'm a product manager at Cisco Systems. The question I have is, how close are we, or rather, can you share any success stories in the world of predictive analytics? Most of the things that we talked about is analyzing the existing data and drawing some insights out of it. How has it actually helped doing predictive analysis, and can you share any success stories in that area?
Maybe I can talk about a little bit on the electricity grid itself, and I think it's a really interesting example of predictive analytics. If you know about the electricity grid, one of the key challenges is that there is very little storage of electricity in the grid, which means that whatever is generated has to be consumed instantaneously. And so anytime you turn on the light bulb, there has to be a generator that has to adjust its output to meet that extra need for electricity. And to be able to manage this unpredictability on the consumption side, there is a huge inefficiency that is built into the supply chain. So for example, to manage just 0.5% of the hours, the demand on 0.5% of the hours, about 10 to 20% of generators are kept online so that they can meet this peak demand. And on an average, you have twice as many generators as the average demand. In US, that means it's about $400 billion of extra infrastructure investment. Now, this problem is even made worse when you put solar and wind, because the supply, which was inefficient, now also becomes intermittent. So we are able to now, with big data, forecast every individual meter. We can generate 1 million forecasts every 10 minutes as the weather patterns are changing, to be able to precisely tell what's going to happen on every home, every transformer, every feeder, which means that these generators can be run in a much, much more efficient manner, so that you don't have to keep as many generators on the standby, and you can improve the overall supply chain, for which everybody benefits. I mean, the utility company could also ultimately the rate bears out of it. And this was just not conceivable just a few years ago.
I think it's fair to say big data was fundamentally created to drive predictive analytics around things like search, which is predicting, well, what is it that you're interested in when you type in a term, or advertising like Quantcast real-time lookalikes to find who's going to be interested. Does that predict your interest in this thing? But subsequently, it's expanded into many other domains where you see the opportunities to do things like predict failures of devices to proactively service them before they break. Use the signals, the features in them to say, let's dispatch a crew and minimize our expense instead of waiting for it to break and all the cost and complexity of having an outage.
Yeah, we've recently seen a healthcare example where they're predicting the probability of a claim being registered. So earlier we know the traditional thing is you have all the business rules in your code. You'll have a PL SQL if you're running Oracle or whatever. But now what they want to do is they want to have machine learning algorithms on data. They have it, they know the input data, they know the output data. The algorithm knows how the data is being transformed. So the algorithm is like dynamic, it learns and it predicts. So we have seen that being successful. And also we have know of anecdotal information about a lot of oil companies using predictions to define the success of an oil well, right? It's based on past parameters, based on the soil characteristics, how it's being tested, and all that. So if they don't have any predictive capability, they'll be spending a lot of money drilling a lot of wells where there's no oil.
You're absolutely right. In fact, I'm involved with 3 such companies who are doing it right now around the world.
Yeah, and then
predictive analytics is driving it. In fact, one more thing I want to add here: predicting the traffic flow and being able to prevent the congestion in a city. That's an example that we've done. Multiple cities in Singapore and Europe. There's a very well-published study on that as well. And for all the privacy beggars over there, think about what the big data has done for counterterrorism initiatives. Being able to predict a terrorism attack and prevent it, that's what big data has done for us. Not many people realize it, but very recently, after this NSA thing broke out, there was a statement made that we have prevented a number of attacks, not only in the US, around the world, just because of the use of this technology. So they are good examples of predictive.
Definitely, I was also interested in specific examples from these companies. So thank you.
Kathy?
Yeah, so I had an opportunity to work with a European-based startup last year for about 10 months, and I helped them start a site here. And one of the customers that Feedzai is a company Feedzai worked with was the third largest wind farm of the U.S. And what predictive analytics helped the customer do was to predict whether they're going to have excess energy or shortage of energy. So there's always an SLA agreement with the wind farm's customers, and if they don't meet, it's very expensive to pay the fine. And if they had extra energy, it's just sitting there, not doing anything from generated from wind. So they were able to do spot trading within to get the data and insights within ±2 hours, so they can do the spot trading, buy some if they didn't have enough, and sell some if they had extra. And the other piece I will share is the other one I just heard the other day is that LinkedIn is doing some prediction on what your next job is. So I have some friends who don't quite know what they want to do next, and maybe this will tell them what they need to do.
One last question there.
Hi, my name is Karthik. I work at Juniper. From what I understand, you guys have picked up different aspects of the data, and you guys are working on it, and you call it big data. So it's like a very general name for how you use data, right? So does that mean that if I can pick up raw data in any form, like a picture, and if I can make sense out of it, and if I can monetize it, it's big data? Like I look at a picture, and I can sell that picture to 5 different consumers. Let's say I take a picture, and I give it to J. Crew. This guy has clicked 10 pictures in, he was trying your jacket. That means this guy likes your jacket. That's a way to monetize data. It's a kind of data. And I can send a picture of a food item, say to McDonald's that this guy has been clicking this picture 10 times, and so this demographics love this kind of food. So is that big data too?
Yes, I think Ron had a good definition earlier. Like whatever your current system cannot do, if you have a problem, you can term it as a big data problem, and the big data technologies like Hadoop will enable you to do it. You have a very valid example, right? Somebody posted a video to YouTube. Coca-Cola wants to know if there's a Coke product in that video. Or any company might be interested, right? Or people viewing pictures. So that's a big data. That definitely is a big data, or it's a compute, right? Big data is not only the volume or data. Sometimes it's also the compute, which is an issue. Like what kind of processing you need to do, what kind of algorithms you need to build to figure out those patterns. So definitely that's an issue. If that's a big data challenge or issue if your traditional systems cannot do it.
And depending on my source of what I'm kind of evaluating, I may or may not need Hadoop, right? If I'm analyzing a picture, that can give me a lot of different things. For that, I don't need Hadoop. So basically, I don't have to mix Hadoop with big data, right? It's just a way to analyze raw data.
Right. There's a lot of big data technologies depending on what your need is. Right. People do analyze images in Hadoop, but if your focus is on an image comes in and I need to apply a machine learned model against it in real time, that's probably not going to happen in Hadoop. I might have taken 1 million images like the New York Times did and analyzed them in Hadoop and built a model that I can then use to quickly score features of that image in real time so I can respond as it comes in and say, it looks like it's a this, or you might be interested in that. And that the real-time technologies might include something like Storm for distributing your processing. It might just be a NoSQL database where you can have characteristics of different elements of the picture that you look up in real time. So there might be a number of technologies that come into play that are big data technologies other than Hadoop.
Yeah, like pictures is a good example. I know, like LA airport, right? I don't know if they still do it, but they photograph you at least 2 to 4 times when you're in the airport. There are algorithms to compare it with the wanted thing, and if there's a match, somebody will come to you. So all that needs to happen, right? So most major airports, that's an issue. They have to take your pictures to do it like near real time, like as soon as they can. So you're still in the airport and they can identify. So it's all there.
All right, I know there are a lot of questions. What we need to wrap up, I've been given the hook there. So I have a final rapid round, and actually the speakers will stay on for 15 more minutes after this. So we'll do this rapid round, and after that we'll adjourn. So are you guys ready? Panelists, wake up. All right, yes or no answer. All right, so more data beats algorithms. Yes or no?
No.
No.
Kathy?
Yes.
Yes.
Wonderful. We have an even split. So we can have another panel on that if you want later on. All right. Final question of tonight. Each of you, in 140 characters or less, one final tweet-worthy comment about big data and monetization. And people out there can start tweeting. Go, Ron.
Big data is going to drive efficiencies across the economy, and the opportunities for businesses and entrepreneurs are endless. Count it out. I bet it's under 140. Come on.
Revenue, cost, risk, and there are ways to amortize the cost of identifying the right solution for each problem. And opportunities exist in... Count it out, it's less than 140, I'm sure. Okay. Revenue, cost, risk, opportunities exist in each space. Amortize cost and focus on opportunity.
All right, Krishna.
Yeah, if you want an exit in the next 2 years, start something in big data.
All right.
I'll use our standard one. Big data is the cheapest, cleanest source of power.
Wonderful. With that, let's all join hands and thanks to our panelists for all participating today. Thank you very much. And with this, we close our event today. We learned a lot, and stay tuned for more programs from the Big Data SIG and more programs from TIE. Thank you very much.